Hi folks, and welcome to a new tutorial. And this is for a brand new Ryzen system. We're going to use the AMD Ryzen 7 8700G chip, which is a brand new chip out at the time of doing this video. And we're going to do this build using the all new Commodore 16. We've never done a tutorial with the Commodore 16 before, so it's about time we did that. What else before we begin? The motherboard we're using is the Gigabyte A620i, and it needs a flash ROM update. So we're going to do that first. I'm not going to go over this too much because really you need to know what you're doing, and in most instances you're going to be able to buy a motherboard that you can actually use the new Ryzen chip on it anyway, but I just wanted to go over it briefly and show you what I'm doing. So before we actually get into the build, we're going to flash the BIOS. I'm going to do that now, so let's crack on. Okay, so I've taken the liberty of taking the motherboard out of the box and placing it on top so I don't scratch my work surface. I've put some power, connected some power to it, but other than that there's nothing plugged in, attached. There's no CPU, there's no RAM, nothing. And what we want to do is something called Q-Flash the BIOS and update it to the current newest BIOS at this moment in time. I'm not going to show you how I've actually put that onto the flash drive, but you can. I'll watch the tutorial, which I'll put in the link, and it's by a guy. Right, his channel is called Mike's Unboxing, and it was a very good tutorial, and basically that's how I'm doing this. So the reason why we can flash this with nothing attached is because when a shop has a batch of motherboards and AMD produce a new chip like they just have, and the motherboards won't work with this new chip, the motherboard manufacturer will give the a new BIOS update, and they've made it so that the shop owners do not have to install all of the equipment to do flash. So they don't have to put the CPU in, they don't have to put the memory in, because if they had, say, I don't know, 50 motherboards, that's a hell of a lot of work. And also they're sort of like using the motherboards. You don't want to have a used motherboard when you're buying it, and you know, the shop manufacturers would have to take everything back out after they done the BIOS update. So motherboard manufacturers has enabled people to be able to do this without adding all the stuff in, and I thought it would be really nice to show that. So I've actually flashed the flash drive, and I'm going to plug it in, and it's a specific port that I've got to plug this into, so I'm doing that now, and I've got it upside down, and literally all I have to do is, there's a button here, I've got to press that button for 3 seconds, and hopefully I should start seeing, one, my fan will start operating on the power supply, and two, I should see a blinking light on here. So 1, 2, 3, I've got a blinking light. I don't know whether you can pick that up. So this is where you could do something seriously wrong and you could brick your motherboard, hence why I don't want people to follow this. To be fair, because the chip's only just come out, there's a lot of motherboards not flashed yet, but all the people that own these, all the shopkeepers and all that, will be flashing their motherboards in this particular way. So by the time you watch this video, the motherboards you will be buying will all be supporting the brand new chip. But the thing I want to show you is, I don't know whether you can still see that flashing light, but if we now turn this power off, we've basically bricked. Might as well throw this motherboard away, it won't be any good. So I cannot touch this until this update is complete, and what will happen is the light will slowly, it's starting to do it now, so it's slowly flashing, and that means, if I turn it up again so maybe you can see it, that means it's actually installing or burning the new BIOS onto the ROM that's within the motherboard. So it's doing that now, and then once it's finished, the light will go out and the fan on the on the power will stop running, and that's one of the main reasons I didn't use a Pico-PSU to do this, because obviously I want to see the fan turn off. I don't want to touch this and unplug it and brick my motherboard. So so we're just going to wait now until this is finished and pick up from there. So as we can see, lights out, the fan is now off, so that is the BIOS flashed onto the motherboard, so now this motherboard can accept the new Ryzen CPU. So with the power removed from the motherboard, we can begin the installation process. And of course the first thing I want to do is install this amazing chip. If you have a look at the box, it's absolutely huge, and if I just move this to the side so you can actually see, the bulk of the box is something we don't need on this build, which is the heatsink and fan, which is huge. So obviously that's not going to fit into our C64X chassis, so the only thing out of this box we need is that, which is no bigger than the actual box itself is no bigger than a 2.5 inch hard drive. So let's just have a look at this. So this is this new Super Ryzen chip, the Ryzen 7 8700G, yeah, let's crack on. So the first thing we want to do is, we've got a lever here, and what I want to do is push it down and out and then lift it up, and then we can release this bit of plastic and lift that up, so that is exposing all the little prongs, or the little, I don't know what you call them, sockets or whatever, to fit the CPU in. And what we've got to do is, on the underside of this, we can see that if I bring this up, you can see an arrow. Is that focus? An arrow there. And actually, if I use my screwdriver as a pointing device, we can see embossed on here as an arrow. These two arrows have got to line up, so that's the corner to corner that we're doing. So if I put this in, it's actually slotted in the right place. There's grooves around it, so to locate it exactly into the right position. So we've done that now. So what I want to do is bring this back across, and this is just clamping it down into place to stop it from coming out. And then if I bring this over, yeah, it does. That can't be right, surely, is it? Yeah, it is. Right, so that is very strong, pulling this lever down, really strong. Putting that in, that's going to go nowhere. So that's the chip installed. So that's one job done. The next job we're going to do is install the Dynatron cooler, heatsink blower fan, basically. And here it is. So this is going to enable us to direct the flow of hot air. If we're going to sort of like, if I lay it across like this, it's going to direct the hot air out this way, and then we've got the plastic vent duct that's going to vent it out through the rear of the Commodore 16 chassis. So the first thing we've got to do is remove these 4 screws, because we're not fitting the stock fan, heatsink fan, that's in this gigantic box. Yeah. We're going to install the Dynatron, so look, we've got to take all this off. So if we remove 1, 2, 3, 4, take these 2 plastic bits out the way, and then if we turn this over, we'll see that the Sorry, I was just having a look at that. So now we're ready to fit the Dynatron fan into this position. I'm just going to line this up and make sure it works and sits in the screw holes. Make sure it does. Yes, and yes. So it does. So we know it's going to line up. So now what we've got to do is get some thermal grease. So I've got two options here. Now you can choose your own thermal grease. It's just what I had. So I've got Noctua thermal paste, and then I've got Cooler Master, and I think the Dynatron fan, is it Cooler Master? I can't remember now anyway, but I'm basically going to use the one that's got the most in. So I'd say it's this one. So the amount of times I've done this and done it and put too much on, the best, you could put dollops all over it, but I've been told the best thing to do is put one dollop in the middle, and then when the heatsink goes on top, it's going to squirge it out across the whole base of the top of the Ryzen chip. So let's do that. So let's get the blower fan in the right position. So we want it blowing out this way, because you could have it the wrong way and have it going across the other side. So actually, if I turn that round, because otherwise I am doing it wrong. So if that's the back, yes, so we want it here like this. So I'm just lining it up with the screw sockets, and you can immediately feel it squash. You can move this, you can feel it moving around on the paste. And so what we've got to do now is, once we've got that in, I always like to just get a couple of turns on each screw so that I'll know it's actually screwing up, and feel them. So it's located, they're all located in the right position. So now we can carry on and do this up. Okay, that is pretty good. Right, I've had to do a change, and I didn't want to film it because we've already filmed the original fan going in, but those of you that with astute eyesight will see that I've actually changed the fan. So this is the original fan that we just fitted. As you can see, it's quite, you know, it's a lot bigger than the A18. So this is the Dynatron A45. This is the A18. And the reason I've changed it out is because further along the build, I discovered that the A45 fan is simply too noisy. It's like a jet engine. So I've decided to put the A18 in, which I know is a lot quieter than the A45. It's not as efficient with this chip, so this chip runs slightly hotter than what it would have done, but I think the noise level is a lot more acceptable, shall we say. So let's move on with the build. The next thing to do is the memory. I've got two sticks of DDR5, and these are two 16GB sticks of RAM. Now before I put these in, you can see that there's a little slit there. Now that is not in the center, it's offset, and the reason for that is so that you can line it up with the opposite part of the slit that's in the DIN rail, and you can fit it round the right way, because otherwise you would have a tendency to fit the RAM around the wrong way. So I'm just going to use a rocking motion side to side. You can hear that click. So that's the first bit. Let's do the next one. Also, while I'm talking about this RAM, the other thing is we need to have this as dual channel. Dual channel means we need two sticks of DDR so that it's running off both as opposed to one, because this Ryzen chip really does need 2 sticks of DDR RAM. Doesn't matter what size memory it is, you could have 2 sticks of 18 gig, but 2 sticks of 18 gig giving you 16 gig in total will work a lot better than one individual 16 gigabyte stick of RAM. So bear that in mind. Whatever you want to do, make sure you put it across 2 sticks, whatever memory size you want. But we've got 32 gig, 16 on each side, and that is going to mean that the graphics processor part of the Ryzen system will be working to its maximum, and you really do need the dual channel working for this to give us maximum results. So the next thing we're going to do is install the M.2 hard drive. So here it is. Again, this has got a slit, if I've got it around the right way, which is there again, which is offset. So I'm just going to simply put this in, raising this end here where my finger is to about 30 degrees. And then I'm just going to simply push it down. I've got the screw already loaded onto the end of the screwdriver. I'm going to screw that in. And the last thing to do for this, building this motherboard up, is fit the 150 watt Pico-PSU onto the motherboard. So this has got a little latch there that clicks into place. The opposite part of that on the motherboard socket is there, so I'm just going to put that in, and I'm going to do that rocking motion again. If I can get this in, I'm going to lift that up like that, and I'm just going to click it side to side until it clicks in, and there we go. That's as simple as that. So with these modern builds, I can honestly say that that is a full computer now. So if you plugged in a keyboard and a mouse and then plugged in the power to this, this will boot up. And if you've got an operating system installed, it will boot into the operating system, because that is all you need for this system. So we've got the RAM, we've got the processor, we've got the hard drive, we've got the motherboard. That's everything you need to make this work. So the next thing to do is put this into the Commodore 16 and then close the case up. So let's do that next. Something else I forgot, and that is on this build we're going to need this USB 3 riser cable, and the reason for that is because our USB socket is here, but the actual cable that comes from the Commodore 16 will not fit because the memory's in the way. So what we've got to do essentially is bring this up above the memory, and we can do this by this USB 3 riser. I just call it an extension cable basically. So I'm going to plug this in now because it's going to be easier to get to this now than once it's installed into the Commodore 16. So that's basically in effect giving us the USB 3 plug here as opposed to down there, and our cable will fit that a lot easier. So I have the bottom part of the Commodore 16 case. The first thing I'm going to do is actually remove the USB 3 side ports just to get the cable out of the way, and we do need access to this section underneath anyway to plug our wires, to put our wires in. So what I'm going to do is bring over the completed motherboard, roughly put this in place, and then I'm going to bring across the rear I/O shield. So what we want to do is line this up with the actual motherboard, and I'm just making sure that there's no tags in the way of this, no springs that come on the back of this. I don't know whether you can see the springs that are on the back. We want to make sure that they're not fouling anything. They're not. So I'm going to get my head in the way now. I do apologise, but I want to slide this in down the back like that. So I've just slid this down. The rear I/O shield's gone into some slots on the back of the actual case. So that's in situ now, and I just want to make sure everything's set, which it is. So what I want to do now is get my motherboard screws. This comes in the kit. I've already got mine out because, as you might have expected, I've already done this build run into lots of problems, ironed them out, and that's what I'm doing now. I'm installing this, showing you how to do it without any problems. So the first thing I want to do is put my motherboard screws in, and I'm going to try and do this without me shaking, which is difficult. Maybe better to do it with this screwdriver. What we don't want to do is we do not want to tighten these up until all 4 are in place. There's a reason for this, and that is if you tighten one of them up, then it might obstruct you putting the other screws in, because the motherboard might have moved so that the other screw holes don't line up. So if you get them all in place and just do them up a couple of turns, then we know that they're all going to fit, and then we can do the last turns. So what I want to do now is just check to make sure that the rear IO shield is actually slotted in its place, which it is. It's not, none of the tags or spring bars are obstructing the rear IO shield, so I'm happy with that. So what I want to do now is put some push the motherboard towards the back. You'll probably be able to see it move slightly. We want to put tension onto the back, onto the rear IO shield, and then pinch these screws up. What I'm doing now, and we don't want to pinch them up too much, because we could strip the threads on the plastic part of the case. We just want to pinch them up so they're not going to undo. So that is the motherboard actually put into the case. So let's move on to the next section. So the next thing we're going to do is install the power socket. So this is the power socket here, and it's got the screw, the thumb nut already on that, so I want to take that off. Sometimes they come with spring washers on as well, but unfortunately we won't be able to use the spring washer because we won't have enough thread to get the nut on if we do that. But anyway, so how do you connect these? There's a few things you can do to connect these. We used to do a side panel. I used to call it the power input vent plate, and it had a hole for the power input, so you could put this through the hole, and then it had a lot of holes in it, and you could put a fan next to it. So if we've got those on the site, you can buy one of those. But what I tend to do is drill a hole here. It's difficult to see it because I'm using a black case, but I'll drill a hole there. I think it's an 8 or 8.5mm hole, and then it's an ideal place to put this plug. So that's what I'm doing. I've just fed that through. The wires can go here, so they're underneath the USB plate, so it's a good place for the wires to go. And as you can see that poking out. So sometimes if I put that, like, you can just about see it. These do come with spring washers, but again, like I just said, if we use a spring washer, we haven't got enough thread to put the nut on. So I'm just going to do that up, and then what I'm going to use for this to actually pinch it is a bike spanner, which I found that got the correct size on it. So I don't want to do it too tight. I just want to just pinch it enough so that it's not ever going to come undone again, basically. So that's the power side of things done. We can actually route these cables so that they're above it, so the cables at its lowest, out of all the cables it's the lowest one. It just makes sense to do that. So the next thing to do is install in this instance, the hard drive docking station. But we've got a problem with these docking stations, they're built, when I've got our partners to build these, they're built for power embedded motherboards. That means you don't have a Pico-PSU. The power comes in onto the board itself, so you plug directly into the board, and in those instances this power plug there'll be one on the board somewhere to plug this in. But of course we haven't got a power embedded motherboard. We rely on the Pico-PSU, and there's no power connections that will fit this. So what do? Well, I'm afraid at the moment there's nothing that we offer as a solution. So what I've had to do, here's one I prepared earlier, is I've actually cut these wires and put on a Molex plug instead. Now I'm not going to show you guys how to do that, but I will leave a link to the video that I watched where the guy shows you how to do that. It's very easy. It's a lot easier than what I thought it was going to be, but that's what I've done to enable this hard drive's docking station to fit. So I'm going to offer this up. Again, it's quite difficult on this build because everything's black and it's hard to see things, but I'm going to get my screws to screw this docking station into place and use my tiny screwdriver. Now if you was using a different colour case, maybe it might make it a bit, it's just so difficult because normally when you see through the hole you see the colour of the case, but the case is black, so you can't see the holes at all. It's very difficult, but I've managed to do it. I should have picked a different coloured case to build on, but I wanted to do the Commodore 16 because I've never done the Commodore 16 under a build. We've always used the VIC-20 or the 64, so I just wanted to do one of the other variants this time. I'm using the same principle I did for putting the motherboard in. I haven't tightened any of the screws up until they're all in. So all 4 screws are in, so I'm just going to pinch these up. Again, I don't want to pinch them up too much. Or any tiny little screws, we might strip the threads. So I just want to just pinch them up. Okay, so that's the hard drive dock installed. So the next thing we want to install is put the USB 3 back into place. But before we do this, I need to install this plug, this power plug, which goes in here. But what I want to do is utilise this bottom part here to put this in. So if I bring this in and plug this in, it'll only go in one part of this. I will take a picture of it once I've done it. So it goes round, I think, it goes round that way. So it's got a little latch on the side of it that corresponds to the latch on this side of the socket. So I'm going to plug that in. There we go. Only goes in one position. And then what I want to do is feed the wires down there and then put this back in to its position like that, and then I want to put these screws in taking care not to screw into any wires. Make sure the wires are out the way of the posts. So that is really good because it saves us using cable ties. They're all nice and neat. And the next thing to do is actually plug in the USB into this new USB riser. It plugs in really easily. There we go. And then we just have to route this around somewhere. Oh, probably down there. And that will work quite well. So the next thing to do is plug in the hard drive docking station. So let's do that now. So we want to route this so that it matches some of the other cables. So that's the SATA cable. Again, you'll just have to consult your manual as to where they are, but we can see it's here. So the next thing to plug in, well, the only thing left to plug in apart from the keyboard is the power into the hard drive docking station. And again, this is plugging into the new Molex connector that I've actually made for this. So this sometimes is a bit finicky because it's not a built one from a factory, and I've done it myself, so it's DIY. lining them up sometimes because it can be pretty difficult, but that went in really easily. So that's those wires there. So the next thing to do is come in and plug in the brand new fan duct. So this is built just for the Dynatron A18 fan and this Gigabyte A620I AX motherboard. So it's really easy to fit this. So what I want to do is bring in my finger guard and put it onto the end of this, and watch how simple this slots in. So if I just put that over the area and slot in, how good is that? So that is all the hot air now will come out. It will be sucked through this, through underneath and through the fins of the heatsink, and it will be sucked in and blown right out the case, whereby that will keep the whole case cold or cool, because all the hot air is coming out the back. So all we've got left to do now is a little bit of cable tidiness, but we can do that at the same time we connect the keyboard and the power LED light. So let's do that next. Okay, so I've taken the liberty of putting the keyboard onto a little bit of bubble wrap so I don't scratch the keys while it's upside down. And what I want to do is bring over these wires. Now you're going to have, if you're not using the same setup as what we're using, you're going to have to consult your motherboard as to where the corresponding connections are on the motherboard. So straight away we need to find out where the USB 2 header is. I know it's down here, so I'm just going to put that in. Now it's really important to get this round the right way. So in our manual it shows you close up the correct way to plug these in, because I only go one way round. So please consult the manual and have a look, and then use our manual and the motherboard manual to actually find where that is. So we can show you how to plug them in, but you need your motherboard manual to show you where they are on the motherboard. So that's the USB 2 header, and then the next thing to plug in will be the power switch and then the power LEDs. So I'm plugging these in. I'm going to take a picture of this so you can actually see these plugged into position if you're using the same board as what we are. So that's that done. So the next thing to do, and the last thing to do before we close this case up really, is to create a little bit of what we say in the trade is cable tidiness, and that is try and make the cables, you know, relatively tidy. So the first thing I'm going to do is take one of these cable clamps, and I'm going to stick this on the base down here. I'm going to note I'm actually putting the cable tie in. Make sure you put it around the right way. I'm going to put that here, and then it will enable me to clamp the cables themselves here. So I like this idea, it's good. So that's one done. Sometimes you can group some cables together, which I think I'll do here. So if you group them together, they tend to stay in one place because you've got two opposing forces cancelling each other out. So if we put them both together there, I think that's a good thing. And the other thing to note is once you've obviously done this, you need to cut these cables. So I'm quite happy with all the onboard cables where they are, to be fair. I don't think they're in anyone's way. So I'm going to clip these. So they're snipped off. And the next thing to do is the actual cables to the keyboard. Now we're it's quite good in a sense, because this build has got no moving parts, because this is an encapsulated fan. So normally what you'd want to do is keep wires away from this area, because if they snag the fan, they could the fan could cut the wires, or the wires could stop the fan and burn the fan out. So ideally you want to get in a position where the wires aren't over there, and the other reason is sometimes that gets hot and you don't want the wires touching it. So what we're going to do is we're going to put one of these cable clamps on here, and it's going to involve a little bit of jiggery pokery to get this to actually work. So I'm going to put that there. So once I've put that in, the best way I've discovered of doing this is just to do the USB 2 wire, because the LED light and LED power switch cables are they're not long enough to route them round really. Our partners didn't make them long enough. They're long enough, but when I used to build these, I used to have longer cables. Never mind. Anyway, let's snip that off. So at least we've got the USB cable is away from that area. So the next thing to do is offer this up, and I might have to bring this out a shot to get this in. I normally do it round this way, but it's quite difficult to get this to line up with the rear I/O shield, because it's got to slot down into its position. Everything's clicked in, but I'm not happy with the I/O shield. Oh, now I am. Right, it's clicked in now. So all we need to do now is do the screws up on the underside. So we've got 6 screws to put in. Now what I will say is, if you haven't started this up for the first time, now is a good time to do it before you do the screws up, to make sure the system works. I know my system's going to work. I'm not being big-headed, but I've already tested it anyway. So I'm going to do the screws up and show you how to put these in. I'd normally put 1 screw in each hole, and then do them all up at the same time. One thing I forgot to say is it's always best to make sure that there's no wires. I haven't done that, but I trust to know that my wires are away from everything. So all the screws are now in, and I can do these up. Again, we don't want to strip the threads, so all we want to do is just pinch these the slightest of pinches. As soon as they get up to the point where they're tight, we just want a slight pinch to pinch it up. And it's good to do this on a bit of bubble wrap so you don't scratch the keys. Sometimes as the case clips together, you will hear a little, click. But if you've got the case clicking together already, it might not do that. I think this one will click. There we go. I just had the click then as they manoeuvre themselves together. So that's everything done up. So as you can see, just catch the light, you can see that it's solid. A fantastic Commodore 16 that is absolutely amazing, and this computer cannot wait to be turned on. So let's do that now. So after a lot of testing on the Commodore 16 and this brand new Ryzen setup, I can confirm that the 150 watt Pico-PSU will work with this system, but we recommend the 160 watt, and you'll have to use an ATX riser cable and then place the Pico-PSU somewhere else in the system. Now I have to admit, I haven't done that. I've got the 150 watt Pico-PSU in my system, and if you're going to do that and you're going to use the 150 watt, you have to make a little change in the BIOS settings. So I'm at the BIOS settings now, and what we need to do is, at the moment I'm on system info. I just want to show you that we are running the BIOS version F22B, but it might have changed now, and there might be a brand new BIOS, but at the time of doing this video we're on F22B. Obviously we updated the BIOS, didn't we, earlier on? So what we need to do is go into Tweaker and then Advanced CPU Settings, double click that, and then Core Performance Boost. We want to disable this, because that is the problem we've been having, where we've been stressing the CPU and then the system shuts down because it cannot draw the extra power it needs, therefore it closes the system down. So by disabling this, we're minimizing the system shutdowns that you're going to get. You'll have to run the CPU or the GPU to its maximum to make it shut down. So the 150 watt Pico-PSU will work for the majority of stuff that you want to do, but for that added bit of security, then you can install the 160 watt. That won't fit in the ATX slot because it's too tall and you can't close the case down. So you need to get an extension. It's called an ATX cable riser, and you plug it in. I'll show you a picture of that in the post edit. I'll put that in. Anyway, so we've done that. So now what we want to do is save and exit the setup. And now this is going to go and boot into Windows, which I've previously installed on this system. If you want to know how to install Windows 11, then we've got another tutorial on our YouTube channel, so take a look at that and it'll show you how to install this. The next thing I wanted to talk about is the fan control. So I've got it here. Now this motherboard, I've been told by mini-ITX.com that this happens quite a lot now. The motherboard injects some stuff into Windows as it's installing. Sorry about that. It installs, as it's installing Windows, it asks you whether it wants to install the Gigabyte stuff, which is basically drivers and stuff like that. So it's really good, because up until very recently they kept on putting DVD discs in, and you're thinking no one's using optical drives no more. Surely there's a better way to do it. Well, this is brilliant because it installs it for you. So when you get Windows on your desktop is the installation package, and you just click it and it will install all the drivers and do everything, which I obviously did. And now I've got this Gigabyte control center, and if I go fan control, I've put it on manual, and my settings are really low, so the thresholds are set really low, so basically the fan won't come on until it gets quite hot. I don't think the fan's going to start revving up until it gets to like 58, 60 degrees, something like that. Yeah, 60, I think it's 60 degrees. But you can change the speeds, so you can have it on normal speeds. The native silent, as you can see, it's quite noisy still. So you can already hear that the fan's starting to rev up. But I wanted to show you the full speed. Listen to this, how loud it is. Now it's quite loud at full speed, but that's nothing compared to the A45 fan that we installed in this system first. That is like a jet engine, and I think I've got a little bit of footage to show you so you can hear how loud that was compared to this. So this is relatively quiet compared to the A45. And I think you'll say the same thing. That's why the builds took so long, because we had to change settings and change different things because one, the fan was too noisy, and as you can see on the manual, it's come right back down and it's silent again. I'll stop talking for a sec. There's no noise. It's brilliant. So if you're not using graphical intense applications, you're surfing the web, doing standard stuff, then it's pretty much silent. It's only when you start using and testing the CPU or this GPU, using the actual performance of this and utilizing it, that's when the noise kicks in and the fan speeds up. But what I want to do is, where is it? There he goes. I want to start Afterburner up so we can get the frame rate, and then I want to open Assassin's Creed Odyssey. So this is an old game now. I mean, it was 4 years ago that we first showed this off on the Ryzen build. I think it was 3 or 4 years ago anyway. But at the time it was a brand new game, but now obviously it's 3 or 4 years old. But the thing about it is it's something that we can test it and compare it with. So we can compare it with the old Ryzen system, and also we can compare it to the GTX 1650 Ultimate system that we were selling in the Kickstarter campaign that people have got. Now this compares pretty well to the Ultimate. It's not quite there. It's far superior on the CPU side of things, but on the graphical side of things it's not quite there yet, unless there's better tweaks you can do that I don't know about. We're on about 15 frames a second less than the Ultimate, but for an actual system that you can build yourself, this Ultimate is, you know, sorry, not Ultimate, but this Ryzen 7 8700G is off the chart, considering this is embedded graphics within the chip itself. It's unbelievable. It's unbelievably fast, and I never thought I'd see a chip like this perform as well as it has. Okay, so you can hear that it's revved up now, it's ramped up because we're stress testing this CPU. It's maxed out again. So what I want to do is just show you the graphics. So they're so much better than the original Ryzen. They're probably twice as fast, twice as powerful as what the old Ryzen. So the original Ryzen build that we did, we were running on 26 to 30 frames a second at low settings. This is medium settings and we're on nearly 50. Now all I can say is when we were doing this with the Ultimate build, and I was showing it off to all the backers that were buying the Ultimate Commodore 64 Ultimates, we were running on the medium settings like this, and we were in the 60s, but we're in the high 40s here, so we're about 15 frames a second off. But when you think that was a GTX 1650 graphics card, this is embedded graphics. This is amazing. But anyway, I want to get some frame rates up here by giving this guy a whack. Oh dear. So we're on 40 and he's killed me. We're on 50 frames a second. It is amazing how powerful this system is. I hope you enjoyed the build video with the Ryzen 8700G and the Gigabyte A620 within the Commodore 16 or Commodore 64X chassis, or the C64X chassis should I say. I've really enjoyed building it. It's taken me quite a while, because when mini-ITX actually sent this across, no one had any, but it's taken nearly 2 months to sort it out on and off because of a few problems, notably the loud A45 fan, and getting time with triple axis to design new fans has been a little bit of a delay, and then time for me to actually implement the new designs and test them and everything. But I'm sure you'll find that, or you will agree that this Ryzen system is amazing. Sorry I didn't have time to show you any more of the graphics, but there's plenty of people out there now that's explored how versatile this GPU is and how good it is. So I'll just put a few links in there for you to look at those videos if you want to. But the main point was to get this build done to show people how we've worked out how to build one of these systems and get everything in it and power it. It's taken a while. I think the video is going to be quite long, but I hope you've enjoyed it anyway, and we will catch you next time. And before I go, please, if you like the video, don't forget to subscribe and click the little bell to turn notifications on so you know when we bring out a new video. But anyway, that's all from me now. Thanks very much for watching, and we'll see you later. Bye.